Bismillahirrahmanirrahim. Good morning everyone, I hope you're all doing well. Today I'm going to present to you my work which is entitled The Waste Brick Effect on the Concrete Durability, which I will participate in the second National Conference on Applied Science and Advanced Materials. Knowing that the participating members are Dr. Marwa MOUDJARI, Tariq Bouzid, Zahari Sela and Said Ikan. Let me introduce this presentation by an abstract to facilitate understanding of the work content. For a long time, researches are carried out in universities and the private sector to study the behavior of recycled materials from construction debris and road debris, from demolition as aggregates in the concrete manufacture. Since the disposal of waste of these materials presents many problems, such as the space occupied by the storage sites, the cost importance, impact on the environment. So, it's necessary to find a way to recover and reuse this waste and therefore find another source of aggregates. The main purpose of our study is to demonstrate technically the possibility of partially or totally using aggregates from demolition brick waste with an increasing rate 30%, 50%, 70% and 100% as a substitute for natural aggregates in the manufacture of concrete. The characteristics of recycled aggregates as well as those of fresh and hardened concrete based on these materials are analyzed and compared with those of controlled concrete, 100 natural aggregates. The results obtained led to the conclusion that it's possible to manufacture a concrete based on demolition brick aggregates with physical and mechanical properties comparable to those of ordinary concrete, with a partial rate replacement of natural aggregates by recycled aggregates up to 50%. This work is divided in two important parts. The first part is the characteristic of the materials used, such as cement, sand, and gravel. We start by the cement. The cement used during the study is sulfate-resistant cement from Ain Kbira Astif. The second materials is the natural sand from fraction 0.3 and brick sand 0.3, the gravel 8.15 and the gravel 50.25. These are their characteristics which are presented in the following table. Also the granulometrics curve of quarry sand, brick sand, gravel. This is the brick sand. And this is gravel 8.15. Finally, this gravel is 15.25. Okay, that's all I would like to say about this. Now, let me move on the next part, consisting the concrete formulation. In our project, the method of absolute volumes developed by Professor Skramtoyev has been adapted to formulate our concrete. The complete formulation of the 1 meter cube concrete mixtures for respective cement dosage of 358 kilogram for meter cube is in the following table. This brings me to my third point about analysis and discussion of results. This part actually is divided in two axes. The first axis is fresh state concrete and the second axis is hardened state of concrete. We start by the fresh state. At this stage we study and inspect the concrete in its fresh state. In the beginning we started by the slump test. As the picture shows, and sag values or slump values of each concrete type are shown in the following table. And from the curve which shows the different slump values, we note that the mixing water actually used to ensure this slump increase according to the rate of substitution in recycled aggregates on the one hand and type of aggregate on the other hand. Now, Let me turn to the report EC and volumic mass or density. From the curve of E for C, this ratio of the same concrete composition increases proportionally with the rate of recycled sand in the concrete mix. Above the curve of volumic mass, we try to make a comparison between the hard and the fresh state. So, the density of the prepared mixtures are variable, depending on the variance and the age, 7 and 28 days. This is attributed to the evolution of cement hydration reactions, which fail the pores in the mixture. Also, this variation can be explained by the percentage of introduction of brick sand, either by addition or substitution. Finally, we will discuss about the last test is the compressive strength as shown in this figure. According to the curve and to this analysis at 7 and 28 days, it can be concluded that the compressive strength decreases markedly as soon as the rate of replacement of material aggregates by recycled aggregates exceeds 50%, and that this reduction can exceed 10% of the resistance of the control concrete, so 100 natural aggregates. In the last, I will conclude my work, my presentation by a conclusion. At the end of the study, the following conclusion can be drawn. The densities of the prepared mixture are variable depending on the variance and the age, 7 and 28 days. It is noted that the density of the different mixtures increase following an increase in the percentage of recycled sand in each concrete mixture. The types of concrete batching are prepared with an imposed slam between 7 and 15 cm. The report or the ratios E for C ratio of the same concrete composition increases proportionally with the rate of recycled sand in the concrete mix. According to this analysis, at 7 days and at 28 days, it can be concluded that the compressive strength decreases markedly as soon as the rate of replacement of natural aggregates by recycled aggregates exceeds 50%, and that this reduction can exceed 10% of resistance of the control concrete. Thank you.